A series of 3 different data sets were modeled with linear functions. The figure above shows the graphs of the residuals of the linear regressions. Which of the following statements about the residual plots are true? What do we have here? We have something that looks quadratic. Okay. What do we have here? Something that looks mostly quadratic. And what do we have here? No pattern at all. Now, with residual patterns, if you have things that are patterns like you and like you, then it's not going to be linear. Okay, remember, these guys represent horizontal lines of best fit. So if I were to graph something like this, and all of a sudden I have a picture that looks like that, linear is not appropriate. Okay, all I did was took that guy and tilt it sideways and say that is the same as that, so that's definitely not linear. However, if I were to take this third guy, okay, and say, here, you're a line, and I have a bunch of dots scattered above here, and I have a bunch of dots scattered above there, and there's no obvious pattern, then linear is appropriate. So these guys, since they have a pattern on a residual plot, means they're not linear. Since this guy has no pattern on a residual plot, that guy is linear. So plot 1 and 2 are not linear. Plot 3 is linear. So plot 1, a linear function is not valid because the residual plot does not demonstrate a pattern. That is true. What do I want? Which of the following statements about the residual plots are true? For plot 1, a linear function is not valid because the residual plots does not demonstrate a pattern. I'm sorry, it does demonstrate a pattern, so A is no good. For plot 3, a linear function is not valid. Nope, don't disagree with you, or agree with you. For plot 1 and 2, a linear function is not valid because the residual plot demonstrates a pattern. Agreed. For plot 2 and 3, those have nothing to do with each other, so I'm just going to cross you right out.